because we've played this game so many times with graphs of functions and how they translate and transform and all that kind of stuff that I just have got to believe that either you understand this already or you never will. But we'll just slam through it real quick just so that you can see it. So we're talking about reciprocal functions, graphs of reciprocal functions. So, for example, a really easy one would be something like 8 divided by x. Okay? So if I graph that, you can see that it comes out looking a lot like what we talked about yesterday, where it has the 2 different branches. Okay? One in the first quadrant, one in the third quadrant. All right? So the question then that we need to tackle today is what happens when we, add and subtract things and switch things around and whatnot. So what would you like to consider first? How do you want to change 8 over x? Okay, so let's go 8 over x minus 1. And like I said, we've been through this a ton of times before. What's that going to do?
Move it to the right. Is it down?
Down.
Michaela? Okay, I will come and take a look at that. Yes, if you go a minus 1 outside of the parentheses, as it were, then that takes the whole graph and moves it down. So it's kind of hard to see because those graphs are sort of right on top of each other. But this second graph that we did, which was minus 1, is 1 lower than the original graph. Yes?
Can we do 8 divided by x plus 1 minus 2?
Okay, now when I did this, the first thing that Forrest said was it was going to move it 1 to the right. Okay, how would I have to change this to move it left or right instead of what?
Put it in front.
Put it in parentheses. Yeah, I need to have things in parentheses if I want them
That's what I meant.
to move. Okay, to the left or to the left or to the right. Hey, stop. Okay, so now if I go 8 divided by x minus 1, you can see that the whole graph has been shifted 1 to the right, okay? And so one of the things that we should talk about in terms of these graphs is asymptotes, okay? When you look at this original graph, let me get rid of the new one that we did. What you should notice is that there's kind of a hole in the graph right here in the middle. So why is that the case? What makes that asymptote there, right where x equals 0?
There's no line.
If you consider the original function y equals 8 over x, why would there be a hole or
There's no number. I don't know. There's no y. I don't know.
why is there a vertical asymptote in this graph at x equals 0? Right, because there is no 8 divided by 0. Thank you. So if I look at this function right here, 8 over x, because I cannot divide by 0, that means that in this case x cannot equal 0. Okay? In other words, the domain of this function is from negative infinity to 0, and then from 0 to infinity. Okay? And so that's why there's that hole right there. And the reason why I brought that up is because if I now change this to be 8 divided by not x, but divided by x minus 1, what happens to where that discontinuity of the graph is? Where is it now? It moved over to the right to what?
Oh, so it's 1.
To x equals 1, correct. Because if I look at y equals 8 over x minus 1, and Mary said it a very good way, there is no 8 divided by 0. What number would I have to put in there for x to get a 0 on the bottom? 1. Okay? So in this case right here, x cannot equal 1, which means our domain is from negative infinity to 1, and then from 1 to infinity. Okay, so when we do these things here on the bottom, since it shifts the graph to the right or the left, it also changes the domain of the function. Yeah.
Why can't you divide by 1? I mean by 0.
A number divided by 0 doesn't make any sense. Is that what you're asking me? Why is 8 divided by 0 no solution?
Like, I get that when you get it to 0, right?
No. 8 divided by 0 is not 0. So, for example, when you're dividing, what you're saying is if I want to go 4 divided by 2, what I'm saying is I have 4 things, and I'm going to put it into 2 piles. Okay? So how many things are in each pile? 2. Okay? If I have 0 things, and I want to put it into 8 piles, how much is going to be in each pile? 0. Okay, so 0 divided by 8 works. Okay, but if I switch that around and say I have 8 things, and I want to put them into 0 piles, how many is each pile going to have? Well, I don't have any piles, so that question doesn't even make any sense, right? So there's no solution to that. Okay, so that's a thing that kids get confused about a lot. 0 divided by a number is always 0, but a number divided by 0 doesn't make any sense. Okay, so you have to keep track of that in your head, the difference between those two things. Okay, all right. So does that make sense then? What I'm talking about that asymptote moving to the left, to the right, along with the graph. Okay, let's go back to the first one that we did also. So we also had 8 over x. And then the first thing we did with this before we put it in parentheses was we subtracted 1 from the whole thing. And that moved the graph down, right? Okay, this original graph also has a horizontal asymptote where at y equals 0 right here, okay, which means that if I look at this original function right here, I can't put in x equals 0, and I can never get 0 as an answer to this problem. There's no number that I can divide 8 by and get 0 as an answer. Is that correct? Yes. You understand what I'm saying? Okay, even if I went 8 divided by 300 billion, it wouldn't technically be 0. It would be very close to 0, but it would not be 0. So that's why this graph, as your x's get bigger and bigger and bigger and bigger, gets closer and closer to 0, but it will never get there. So hold on a sec. My question to you right now is if I subtract 1 from that whole thing, what happens to the horizontal asymptote of the graph? It can never equal negative 1. So it moves down to negative 1. Okay? What's that? So yes, now it can equal 0. What number could I plug into y equals 8 divided by x minus 1 to get an answer of 0? 8. Because 8 divided by 8 is 1, minus 1 is 0. Okay, so now 0 will work, but now I can never get negative 1 as an answer, because to get negative 1, this would have to equal 0, because what we just talked about it never
So
will.
basically, whatever you
Right. We'll tell you again. Yeah. So that's
so like, well, there's nothing
exactly.
there,
So
0.
Taylor is summarizing the whole point of this whole conversation. This number right here in parentheses, the opposite of that tells you where the vertical asymptote is. And this number right here outside of parentheses tells you where the horizontal asymptote is. Is that what you mean? Okay. So yeah, that's a really good way of saying that. So if I throw, so let's throw this all together. Let's go, what do? They go no, they just use 1. So let's go 1 over x minus h plus k. All right? So if you start with that thing right there, your vertical asymptote is at x equals h, right?
What does that
Vertical.
say? What?
Yep, up and
What
down
is
1.
it H or is it negative H?
It's h.
And then
Because in our example, remember we went
so
x minus
horizontal
1,
is H.
and your nope, and then your horizontal is k.
A.
Uh-huh.
That doesn't make sense.
Oh.
I don't know. Okay.
The reason why this is x minus h, but then the answer is a positive h is because remember, inside the parentheses is always the opposite. Okay? It always moves it the opposite of what the sign of it is, and you always get an answer that's opposite of what's in the parentheses. Asymptote, A-S-Y-M-P-T-O-T-E.
Okay, you said it's always the opposite.
Right.
But where's the parentheses?
Think of that as being in parentheses.
Okay, so if there
Because
was
it
no,
stays together when it goes under the equation.
if there was no KO, the asymptote would be
Right.
0.
Yes, if there was no k, then the asymptote would be 0. Okay? All right?
Wait.
No, not if I'm already.
No, not assignment already. I'm just,
How? Did I go forward? You missed it.
I missed 6 days.
You're the most disgusting person I've ever had to say that. I feel like I done this
Oh my God, that was so many words wrong. That's what
this is for like a doctor's appointment.
okay, so let's put this all together here. Okay?
What is this?
So let's take a look at the function y equals.
X plus
Lane. Let's take a look at the function y equals 1 over x plus 1 minus 2. What are the two things that you can tell me about that function? Forrest?
It's gonna move left 2 and it's gonna move down. I mean left 1 and move down 2.
Okay, it's going to move left 1 and down 2. And so what that means is there's going to be a vertical asymptote over here, 8, at minus 1. Lane, seriously, your attention should be up here, not with those girls, okay?
This is the opposite in parentheses.
And then it's going to be moved down 2.
So far as on.
Okay, and so what that means is now that I know that, I can just sort of fill in the graph here.
You can just make one randomly.
Yep, I can just kind of make one randomly, and obviously that's not exact, but that gives you the key ideas there, okay? It's got a vertical asymptote at x equals -1, and a horizontal asymptote at y equals -2.
Wait, so you just-
Hold on, fourth?
Should the line be on the dotted line, the one that you drew? Or-
No, it gets closer and closer and closer to that dotted line, but it never touches it,
Alright.
okay?
So you don't want it to actually touch that?
Nope, don't want it to actually touch there,
It's only be
that's,
drawn, you don't want it to.
no.
Okay, so
Yes.
how do you determine where to exactly draw the graph?
Well, I just made it so that it was getting closer and closer here, closer and closer there. I just gave it that general shape.
Okay.
Okay, and that's not as exact as I should be doing it. But
If we were, we have to graph it with.
if you wanted to be exact, then you would need to plug in a point, plug in a value for x and figure it out. So for example, you could say x equals 0, okay? 0 plus 1 is 1. 1 divided by 1 is 1, and 1 minus 2 is -1. So I know that when when x equals 0, y equals,
Now, do you do that from?
hold on. Okay, so I totally screwed that up then, and it should be down here.
I have a question.
Wait, what?
Would
Okay.
it be from? when
Hold on
that-
just a second, because this point right here, 0, -1 is supposed to be on that graph, okay? So it's supposed to be way closer to the dotted lines than I made it, but I just freehanded it, and it's all good, okay? So not really worried about that. Mac, you're good?
Okay, we're just more worried about the when.
Yeah, where the asymptotes are.
When you draw it, or.
Never mind. Okay, all right, can someone tell me what the domain of this function is?
How do you figure that out?
What x values can it take on?
-1.
Okay, from -infinity to
-1.
-1, because that's where the asymptote is, and from,
-2 to infinity.
no, still -1 to
What does
infinity.
that uni?
Union, combined with, both go together, union. Okay, what's the range of this function?
Negative infinity to -2,
Yeah,
and -2 to infinity.
okay.
How do you do that?
Basically, all we're saying is that in the x direction, it can be anything but -1, and in the y direction, it can be anything but
Okay, so
-2.
range
You turn that off.
Yeah.
Range
What?
is the y.
Yeah, range is the y's and domains is the x.
Hey, don't put that down, please.
Yeah, I won't do it.
Am I very good at
Okay, so we can also, of course, always go the other way. And given the graph, you should be able to now come up with the function. So you know that you've got a y equals 4 thing going on right there. And an x equals -3 thing going on right there. So that means y equals, now what number goes on top?
y.
1, just go with 1, okay.
Y.
I think if there's a 1, then that means that it's right there at 1, 1.
X plus
You know what I'm
3
saying? So, whatever. X plus 3
plus
No, mine.
plus 4.
Yeah.
Okay, 'cause it's opposite, the x is opposite. Okay, Katie?
We print that one too.
Yeah, it's a 1, shh, hold on. It's a 1 up top because we just decided for it to be a 1.
I thought it was opposite.
Okay.
Why
So
did
it
you
can
do
always be
opposite?
one.
Because I did do opposite. This one, they give us a-
Oh, I didn't.
Oh, it's on the-
Yeah.
Katie, what?
So it can always be one.
It can always be 1. Okay. Okay. There's one more thing that we didn't tackle with our original graph here, and that is what happens if I make things negative, and I make things negative in 2 different ways. So original one, 8 over x, right? Okay, and then what I'm going to do is I'm also going to graph -8 over x. What do you think is going to happen with that? Flip it over the x-axis, y-axis. Okay, well, if you look at the graph, does it matter? No, it's the same thing. So if I think of this as being a reflection over the y-axis, that means this function from the top went to the bottom, and this from the bottom went to the top. Or you could think of it as, I did that wrong. Either way, it works out the same. It's a reflection over the x or the y-axis.
Wasn't our horizontal, what's it called?
Asymptote?
Yeah, wouldn't that just be the same?
Uh-huh.
And our,
Yeah, okay. So I just want to make sure if you see those in your assignment, you'll know what to do. Okay? Okay.
that was an intense day.
That was an intense day.
I didn't have
Wait, I had to.
Yeah, do we have to
What
graph
is
these?
that and all of a sudden?
What?
I got plenty.
That's enough?
Yeah. You know,
Where are you going?
that's a lot.
Okay,